All right, hi geometry people. Giving you a filled in notes page today. So this week you don't have to fill it in along with me and post it up for grades. It's just already there for you. But I thought it would be helpful to go over not only it just in words, but me explaining it on video as well. So this is mostly a vocabulary sheet with the term first thing right here, and then the definition, and then an example or a picture. So the official definition of a circle, if I were to ask you to draw a circle, everybody would draw this, okay? But the official definition of a circle is that if you start at a point P, which is called the center, and you went out a certain amount, and you kept that amount, the exact same amount, and you went all the way around that circle and kept that distance exactly the same, you would trace a circle. So the circle is really all of the points that are the same distance. So equal just means the same distance from the center. Okay, so that's our official definition of a circle. All right, next one is a radius, and a radius is that very first part that I showed you, from the center to any outside edge. That distance right there is going to be called a radius. Okay, so it's a segment. That means it has an endpoint. That means it has two endpoints. One of them is the center, one of them is on the edge of the circle exactly. All right, next one is a chord. So a chord is also a segment. So it's got an endpoint and another endpoint, except this time it doesn't go through the center, but both parts are on the circle itself. That would be a chord. So here is one point, here's another point, and the section in between them that connects those 2 points together is called a chord. Okay, now if that chord happens to include the circle as well, include the center of the circle as well, so if that chord goes from A to B but also goes through the center, then it's no longer called a chord. It gets a very special name called diameter. And remember, we've already learned this once already, is that if you needed to find the diameter from the radius, it's always 2 times the radius. So if I were to tell you that this amount right here is 8, then the diameter would be 16, 2 times 8, right? Okay. All right, next one, secant. So a secant could be a line, and I'm also going to say it could also be or a segment. Okay, and this is a line or a segment that goes through exactly 2 places. So we have X and Y are my 2 places. Now, if it stopped at X and Y, that's a chord. If it goes through X and Y and it goes through the circle and continues on, it's called a secant. Okay, so the reason I said or a segment is I'm going to go draw another secant that actually is not officially a line. It doesn't have the arrows on it, but it's the same idea. If I did this and put a point out here and a point out here and called this G and H, then segment GH would also be called a secant, because you see how G and H are not even on the circle itself. So if I were just to take segment G and H and erase out the other parts, usually you would see them with arrows, but just in case you don't. Okay, if it goes just straight from G through H, but it goes through 2 points on the circle, then it is still considered a secant line or a segment. Good? All right, a tangent line. So a tangent line is a line that intersects the circle at only one place. So it's like a chord that's been shifted out so that it's only on the very edge. So notice we have this point here, PR. Okay, so it could be line PR, it could be segment PR, but it goes through the circle and it only touches the circle at point Q. That's what makes it a tangent line. If I were to scoot this line in just a little bit, then it would be a chord again, or a secant, depending on where I named that piece. Okay, so a tangent intersects only at one place only. It just barely touches the edge of the circle. Okay, and then that point where it touches the circle, it gets its own name. It's called the point of tangency. So it's got that word tangent in it and it's got a point on it, and that would be for just the letter Q, for where the tangent line or the tangent segment intersects the circle itself, where they have the circle in common. Okay. All right, on to our second page. Now these are going to have to do with angles or degree measurements. Okay, so the first one is our central angle. So we have a central angle. So a central angle means it's going to use the center. Okay, so we're going to make sure that we are using the center for our angle. So it's got angle P in it, and then the other two parts of that angle are going to go to the ends of that circle. So this angle right here is considered a central angle. So we'd use the angle symbol and we'd say A to P to B would be that angle. So notice that it's an angle, its vertex is the center, and then the two sides of the angle, we would call them rays, right, are actually radius points. Cool. All right, inscribed angles. An inscribed angle is, we're still looking for an angle, but now it doesn't have to have the center on it. It just has to be inside the circle. Okay, so notice here is my vertex point. So now my angle is called ACB, and now the two rays are no longer radius points, right? They're just chords. Chords, remember, are segments that go into the circle and share the endpoints on the circle itself. Okay, so this is an angle where the vertex is no longer the center, but it is on the circle itself. It's on the outside edge of the circle. So the vertex is on the circle, and so are the two other rays. So those are two chords. Okay. All right, an arc. Now we're going to go to the outside of the circle for a little bit. Okay, so on the outside of the circle, an arc is any point that travels along the outside of the circle between 2 points. Okay, and it uses this little arc symbol. So on some of the assignments that I did for you this week, they didn't have that symbol available to me, so I just used the words in front, and I would call it arc AB. Okay, so arc AB or AB with the arc symbol over it are the same thing. Okay, so this is a portion of the edge of the circle defined by the two endpoints. So this would be part of the circumference, right? It's just a piece of the circumference. It's got a point on the circle, it's got an endpoint on the circle, and it'd be traveling around the circle itself. All right, so we've got two words. We've got major and minor arc, and that's just how big the arcs are. Okay, so if I went all the way around a circle, that'd be going around a lot. We would consider that more of a major arc, right? As long as I didn't go all the way around, okay? And a minor arc would be one where I didn't go all the way around. So their official rule is 180 degrees. So remember, 180 degrees is a straight line. So if it goes more than a straight line across the circle, we call it a major arc. And if it goes less than 180 degrees, we call it a minor arc. So notice if I go from A to B, that amount right there is definitely less than halfway across, right? So that would be considered minor because it's less than 180. And again, remember, 180 would form a line. So if I went kind of through it this way, that would be about where my line would be. It'd have to pass that point for it to be considered a major arc. But on this one, so I have to be careful on this one if I want to say major arc, because if I just give you two letters, so like if I say arc AB, okay, arc AB is go the fastest way you can between A and B, the shortest distance. So usually, not always, but usually when you use two letters, you are going the shortest way. It's going to be a minor arc. Okay, if you use three letters, then you're going to travel through in that order. So an arc that's called ACB is going to start at A, head over towards C first, and then continue on to B. That is definitely more than 180 degrees, right? 180 would have been right about there. So now it gets called a major arc. Okay, so why do I say mostly? Well, what happens, like in the next one, where I have you start at J and end at L. So I could call this JL, and maybe you'd go this way, and maybe you'd go this way, but it's not more than 180, it's not less than 180, it's actually equal to 180, which makes it a semicircle. So this is a semicircle because it's exactly 180. So I could use either the three letters to try to confuse you and go from J to K to L, or I could just say JL and it means go the other way, right? And if I just left it up to you to decide, it would still be a semicircle. Okay, and if it's more than 180 and it's equal to 360, if it's equal to 360, then it is called a circumference. and that we've already done before. Okay, it would be if it's equal to 360. So if it went all the way around the circle from the beginning point to the ending point, we wouldn't really use arcs for that. So that's why it's not on this vocabulary page, okay? But formulas we could be using, we still have our old area formula. Remember pi r squared. And again, we're going to use those pi symbols whenever we need to. I don't think I gave you any homework with numbers in it this time. I think today or this week we're only practicing on the vocabulary and making sure you know what the definitions are and what the pictures are and the words that go with them. Okay, our other formulas from before is circumference. Circumference is either pi times diameter, or we remember that diameter is 2 times radius. Anytime we use diameter in a formula, we can just as easily use radius. We just replace the d with a 2 times r, and we get circumference for that one. And then our new one, and again, this week I don't have you calculating a lot of it, I just want you to be familiar with it, that the length of an arc, so this is how long is that little curvy curve, okay? And the length of that little curvy curve, it's called an L, is going to be equal to the degree of the arc, and then times the circumference, and then divided by 360. This should look a little bit like when we did sectors and we found the area and then found parts of an area called a sector. Remember when we did these and we did these? These were considered sectors. So the area of the sector was the degree times the area divided by 360. So that was to find all that little pie piece area on the inside. To find just part of our circumference piece, we're going to still take whatever that degree is around. So they'll either name the degree up here and say it's like 60 degrees, or they'll name the angle pi piece and say that that is 60 degrees. Okay, so whatever angle they give you, whether they write it on the circle curve or whether they write it near the central angle, either one's okay. We steal that one. And then we multiply it by the full amount around the circle, and then we make a fraction out of it over 360. Okay, again, this week is only focusing on vocabulary and making sure you're comfortable with those words. So you've got one con lesson to do, and then your quiz is going to be on that quizzes.com website. Check your Google Classroom for your assignments and your links. I hope you guys are doing really well this week. Join me on Thursday during our time frame, which is from 11 until 11:30. I thought we'd do just a fun Kahoot game this week so that you can get together with your classmates and play a game online together. Very little math topics, more likely maybe we'll do a cartoon one or a TV show one or music one or something like that. But it won't, it'll be just a chance for us to get together and get some FaceTime with each other and see each other a little bit, okay? So hopefully we'll see you on Thursday. Have a good week, you guys. Bye.